Okay. So last class we stopped over LMD, RMD, and ambiguity of context-free grammar. So let's continue from there. So what is LMD? LMD, RMD, and can you tell me what is LMD?
Leftmost derivation.
Leftmost.
Yes, LMD is leftmost derivation. RMD is rightmost derivation. So what it means actually, it means we start from leftmost non-terminal or variable we start from leftmost non-terminal or variable until we get a terminal. Then what? So we start from leftmost non-terminal or variable until we get a terminal. Then what?
Then move to the next.
Then we go to next leftmost. And this way we will continue. Am I right? Is there any confusion?
No, sir.
However, rightmost
No, sir.
derivation, we start from rightmost non-terminal or variable until we get a terminal. Then we go to next rightmost variable and continue. Do you have any confusion? So let's take an example. Let's take this grammar. Let's take this grammar. E derives E plus E or E star E or ID, and the string we want to generate is ID plus ID star ID. So what should we start our derivation in LMD?
Left.
Left. So now from where should we start? From where? In this grammar, from the start symbol. In this case, the start symbol is E. So E, then what? Then what?
E plus E.
It should be derived to E plus E.
E plus.
Then which E I should take? The right one or left one?
The left one.
Left one.
As the leftmost,
Left.
the leftmost term is a variable, so I have to start from here, right? So what I should put here?
E plus
ID.
E.
Okay, ID. Okay, ID. Now what happened? The leftmost terms becomes a terminal. So
Terminal.
I cannot replace it anymore. Then I'm going to next one. So see, then we go next leftmost variable. Now it is also terminal. Plus is a terminal. So I have to go over here.
E.
Then what should I replace with the
E star E.
E star E?
E plus.
Then again I'm going to leftmost. This is terminal, so I have to take this. What I should put here?
ID.
ID.
E derives to ID, this one. So ID star E. Then which one I should go? This is terminal, this is terminal, this is terminal, this is terminal, this is only variable.
Yes.
So I have to replace this one, ID plus ID star ID. Now see, this one is the string which I want to generate, right?
Yes, sir.
This is the string which I want to generate. So I got my derivation. I got my desired result. Now remember, the whole procedure is called derivation. The whole procedure. That means starting from start symbol to getting the desired result, which is also called yield, is called yield or yield. It is called derivation. And each of this intermediary form, this one, they are called what? They are called what? They are called
Sentential form.
sentential form. Now let's do another RMD. So let's do an RMD. So I have to start from start symbol, no exception. So E should derive what? E should derive what? Let's do E plus E. So I'm right now in rightmost derivation. So I have to start from the rightmost variable. I again replace this E with E star E. Then again, I have to take the rightmost variable. So this one become E plus E star ID. Now this one has become a terminal. This one is terminal, so I have to take this. E plus ID star ID. Now I have to take rightmost ID plus ID star ID. I again got the desired result. But there is a but. If you convert, this is leftmost derivation, this is rightmost derivation. Now if you convert these two line by line derivation step to parse tree, then what we get? So
We'll
parse
have
tree
the same
definitely start with start symbol. This one would be our root E. Then I will put next the first sentential form. So it would become E plus C. Then I put the second sentential form, which is nothing but this becomes ID. Then I put the third sentential form, which is nothing but E star. Then I take the fourth sentential form, which is nothing but putting it ID. Then I put the last sentential or the yield, which is nothing but ID. Now, how do you make sure that this parse tree actually have the same yield? You have to read from top to down, left to right. So if you read from top to down, at first you get ID. You are only considering the terminals. So you get ID plus ID star
Into ID.
ID. So also I get the desired result. Now the question is, if you convert this RMD to parse tree, do you get different parse tree?
No.
You can check. So we'll start
Okay.
from E. So I have to replace this same. Then this one is replaced by E star E. Then this one is replaced by ID. Then this E is replaced by ID. Then finally this E is replaced by ID. Same parse tree. But in this case, the parse tree For LMD, parse tree is generated from the left side. The parse tree, in this case, the parse tree is generated from left. In this case, the parse tree is generated from right. But they are same. They are same parse tree. In that case, can you say the grammar is ambiguous?
No, sir.
You cannot
No.
say the grammar is ambiguous. The definition of ambiguity is more than one parse tree. Ambiguity definition is more than one parse tree or more than one LMD or more than one RMD. But you cannot intermix LMD with RMD. Is it clear to you?
Yes, sir.
Yes, sir.
You have to
Sir,
generate
আর
more
একটা
than.
question.
Yes, please.
স্যার
Yes, please.
পরে করি, আপনি শেষ করেন তারপরে করি।
You have to generate more than one parse tree, or you have to generate more than one LMD, or you have to generate more than one RMD. Because if two LMD are different, then the parse tree is also different. If RMD are different, the parse tree is also different. But if you come up with one LMD and then equivalent RMD, then you cannot say the grammar is ambiguous because they have constituted the same parse tree. Only when two different LMD comes, whenever there are two different LMD comes, then the parse tree is different. That's why they are ambiguous. Or whenever there are two different RMD comes, the parse tree is different. That's why you can say that the grammar is ambiguous, but not like that. So let's take this grammar again. Let's try to come up with different LMD or different RMD or different parse tree. So what can I do? Let's take another one. So in this time, E derives, instead of taking first E plus E, I'm going to take E star. Then what? This E is replaced with E plus E star E. Then this E is replaced with ID. Then this E is replaced with ID plus ID star E. Then this E is replaced with ID plus ID star. Same here. Now it has also an equivalent RMD. What is that? Let's take E. E derives E star E. Then this E becomes ID. Then this E becomes E plus E. Then this E becomes ID star ID. Then this E becomes ID plus ID star. Now if you convert this one, same yield, if you convert this to parse tree, what I get? Starting from E, then put the next sentential form, which is nothing but E star E. Then this one is E plus E. Then this one is ID. This one is ID. This one is ID. ID plus ID star ID. So same parse tree for both of these. But now if you compare these two parse tree, are they same?
No, sir. They are
Yeah.
ambiguous.
Second level, I got E plus. Here in the second level, I got E star. In third level, right side, there is a E star. In this case, third level, left side, there is a E plus E. So definitely these two parse tree are not same. They are not same. That's why this grammar is
Ambiguous.
grammar is ambiguous. Or if you consider this LMD and this LMD, they are different. That's why this grammar is ambiguous. Or if you consider this RMD and RMD, this two RMD are different. That's why this grammar is ambiguous. Always remember the main stress should be given on in the ambiguity parse tree. Parse tree should be different. And when I can get different to parse tree, when I can get to different parse tree, whenever there are two different LMD or there are two different RMD. But please don't mix LMD with RMD or RMD with LMD. Then everything would be collapsed. So it is always better to draw the parse tree. Is it clear to you?
Yes, sir.
Yes.
Yes, sir.
Any more
Yes,
questions?
sir.
Any more question? Is there any question?
No, sir. I got
No,
the answer.
sir.
No, sir.
You got the answer. So let's practice some grammars and try to figure out whether those grammars are ambiguous. Oh, by the way, remember one thing. That is the important point. Now let's talk about ambiguity. I just want to ask you one question. Can a grammar, ambiguous or not, can be understandable by the computer or not? Can you write an algorithm which can understand whether
No, sir. It doesn't have an algorithm.
it does not. It does not. So there is no general algorithm to verify a grammar is ambiguous or not. So how can you come up with answer that a grammar is ambiguous? How can you come up with answer
We
that a
have to
grammar?
check for different parse trees and
So you have to find at least one example, one string for which there is two different parse tree. So come up with only one string with different parse tree is enough to say the grammar is ambiguous. Now let's take some examples. How about this? S derives AS, A or epsilon. Is this grammar ambiguous or not? Is this grammar ambiguous or not?
so we have to come up with different parse trees.
For a string, what would be the string and what would be the parse tree?
The string will be AA.
String will be A. Then how can you come up with two different parse tree?
By derivation.
How can you derive two different parse tree for AA? Let's take this. S derives AS, then this AS derives A. That's how we can derive AA. But is there any more parse tree? Yes. S derives AS, then this S derives AS, finally this S derives epsilon. Am I right?
Yes, sir.
Right.
So two different.
Yes, sir.
One example is more than enough to say this is ambiguous. But is there any simpler example?
So we can take a single character like A.
Wonderful, A. Not any character, A. Only A is inside this grammar, right? You cannot take any single character like BC. BC are not inside this grammar. Am I right, Ankur?
Yes, sir.
So
Yes, sir.
let's take A. In this case, we generate for A. If you take A, still we get two different parts. S derives AS, S derives epsilon. So we get A. And how about S derives A? So two different perspectives. So one single example is more than enough to prove a grammar is ambiguous. If you get any single example, that is more than enough. All right. Any more question about this example? No
Okay, sir.
questions. How about this? How about this one? S derives BS, AS, B, SA, or A. Is this grammar ambiguous? Is the grammar ambiguous? Tell me this.
Sir, I can't see the screen.
Now, is this grammar ambiguous? Anybody, please tell me. These are very basic questions, actually. Let's try. S as first derives to BS, AS. Then I replace this S with BS. All right, guys? And how about this? Taking this, I replace with BSA. Then I replace this S with BS, AS. Right now, the intermediary form is same. B, B, S, A, S. Now let's replace this S with A. And this S with A. This also replace this S with A. This is replaced with A. So what is the yield of this part string?
B B A A
B, B, A, A,
A.
A, A. B, B, A. 4A, right? So B, B, A. What is the yield of this part string? B, B, A. Same, right? Same. But are they different part string?
Yes,
Take
sir.
this sentential form. Here the first level, the sentential form is BSAS. Here the sentential form is BSA. So definitely they are different part string. That means what? This grammar is
Ambiguous.
ambiguous. So remember, whenever this kind of problems comes, whether tell me this grammar is ambiguous or not, you don't have any algorithm to say that, you don't have any general procedure or algorithm to say this grammar is ambiguous or not. You have to apply hit and run method. You plug in some string, then check if that succeeds, fine. If that does not succeed, then you have to go next string. Again, that string might be first level. Apparently, okay, if you take any string, then it might happen for that string you do not get two different parts. But then you have to take another string. This way you have to continue until you get a ambiguity for same string, two different parse string. Is it clear to you? But there is no general algorithm or procedure to actually come up with this answer.
স্যার
You have to hit and run. Yes.
স্যার এরকম হিট অ্যান্ড রান মেথড ছাড়া কি এর থেকে বেটার কোনো ওয়ে নেই?
নেই, আর কোনো বেটার ওয়ে নেই।
মানে বেটার ওয়ে
Ultimate
কি গুগল না?
You can prune using parsing techniques. You can sometimes get easier answers, but ultimate answer depends on hit and run method. There is no algorithm. We are going to learn this more. Why it is not possible?
থিওরিটিক্যালি পসিবল না?
Theoretically, it is not possible.
আচ্ছা
Using parsing algorithms, you might come up with some earlier examples. That means you might get many of the grammars which are ambiguous or not ambiguous, but not all grammars. Is it clear to you?
Yes, sir.
Now tell me why ambiguity is happening in this algorithm. Why the ambiguity is happening in these grammars? What is wrong with these grammars? Why ambiguity is happening? Let's take an example. Let's take this grammar. E derives E star E or ID. Is this grammar ambiguous or not? Simple grammar. E derives E star E or ID. We are doing only the star operation. Is this grammar ambiguous or not? Tell me. Is this
Not
grammar
ambiguous.
No,
Not ambiguous.
It's not.
No, sir. It's not.
It is not ambiguous. Everybody is agree with everybody that it is not ambiguous.
Yes.
It is not ambiguous. How about this string? ID star ID star ID. Now tell me. Can we come up with two different parse strings? Just try. It derives is study. Then this one becomes ID. This one becomes is study. Then this one becomes ID. This one becomes ID. So what is the yield? ID star ID star ID. Correct. Am I right?
Yes, sir.
অ্যাবসলিউটলি রাইট।
Absolutely right. Now let's take this. E derives E star E. Instead of replacing this E with E star E, let's replace this is with ID. Now replace this one with E star E. Now put here ID, put here ID. What is the yield? ID star ID. Same yield. Am I right? Are the different parts?
এটা সেম
They are.
It is same. They are same parts.
Same. No, they're different. Oh, wait.
Nah,
They're
same.
same.
They are same. Am I right? Yeah, you people right. I got mistake. Sorry.
স্যার লেফট পাশে স্যার লেফট
Yes. I'm
Left
sorry.
E.
I'm extremely sorry.
It's all right.
E star E. Let's put this one E star E. I'm sorry. Now
It's
let's
all right.
put ID. So what is the yield? ID star ID. Same yield. Am I right? Are the same parts?
Yes, sir. No, sir.
They are same parse tree. Still they are
No,
same.
no, sir.
No, sir. No, sir.
Here-
They are different.
Let's see. Start from start symbol. E same. Then second layer is same. Third layer on the left side there is the ID. On the other hand, on the right side there is a study. On the other hand, here the left
Study
side
on
there
the
is a
right.
study, right side there is ID. So they must be different, right? They are different.
জি স্যার
Different.
সো
They are
অ্যাম্বিগুয়াস
different. So of course this grammar is ambiguous. The grammar is ambiguous. Now my $1 billion question: why ambiguity is happening in this case?
and sir why are we interested in ambiguity এটা একটা ইম্পর্টেন্ট কোশ্চেন
Because you cannot use any ambiguous grammar in parsing. In the next example, it is getting clear to you why we cannot use any ambiguous grammar in parsing. Just wait, okay? Now, what happened here? This grammar is ambiguous. Why ambiguity is happening here? Let's consider these are not IDs, or they are IDs right now. Next time they are replaced with numbers. This one is 2, this one is 3, this one is 4. All right. So what would be the answer? What would be the answer?
24
24. Answer is 24. No problem about that. But if you go to parse tree, this one is what? This one is what?
2
2. This one is
3
3. This one is 4. Now, if we try to compute this result using this parse tree, what happened? This ID is 2. Am I right?
জি
Then this E would become 2. Go upside. Then what happened? I have to wait for calculation of 3 star 4. Am I right?
জি
Then what happened? At first, I got 2. Then I have to wait for this calculation. Then 3 star 4 would become what?
12
12. Finally, I get 24. Is it clear to you guys?
Yes, sir.
Now, what happened in here? This one is 2. This one is 3. This one is 4. So what happened? I get, at first, this calculation is going on. So what would be the calculation?
6.
Then this one become 4. Ultimately, I got the same answer, 24. No problem with that. But if you recall your arithmetic classes, which one is correct? When I have 2 star, 3 star, 4, which one I need to do first?
স্টার্ট তো যে কোনো ভাবে করলে
না যে কোনো ভাবে
Sir.
করা হয় না এখানে অর্ডারের
Sir,
ব্যাপার
commutative law. So,
commutative law এর
first
সাথে
year-
it does not have anything with commutative law. It is called associativity.
Oh.
Which one we do first?
লেফট
Left one. Whenever there are two multiplication on both sides of a number, we always perform the left operation first. Am I right? Then we perform next one. Is it clear to you? This is called what?
Yes.
This is called what?
অ্যাসোসিয়েটিভ সামথিং
This is called associativity. This is called associativity. And multiplication has left association. So, in that regard, which one is correct first? Tell me. This one or that one? Huh?
পরেরটা
This one is correct. This one, because here actually what happened? 3 star 4 is doing first. Then we are doing 2 into 12. In this case, 2 star 3 is doing first. Then we do the 4, multiplication with 4. So this one is correct according to precedence. No, sorry, associativity. So if we want to maintain associativity, we have to transfer this ambiguous grammar to unambiguous grammar. So how can we convert this ambiguous grammar to unambiguous? We have to
চমস্কির কাছে
somehow we have to prune out this parse tree. So how can we prune out this parse tree?
আর আমরা কি গ্রামারে কোনো টার্মিনাল অথবা ভ্যারিয়েবল
হ্যাঁ,
অ্যাড করতে
চেঞ্জ
পারবো না?
চেঞ্জ করতে পারবো। We have to change the grammar of course. If we keep this grammar, then it would never become unambiguous. Always it is producing these two parts. So I have to somehow change this grammar. So how can I change this grammar? Okay, go to here.
Chomsky normal
Go to here. Go to this line. E derives E star E. Here
we can
recursion is on the left side and also on the right side. Am I right?
Yes, sir.
Yes, sir.
This one is producing
sir.
for what? The recursion is on
E star.
right side. So this wrong parse tree is generating because there is a recursion on the right side. You people know what is recursion. Am I right? What is
Yes, sir.
recursion?
Yes.
What is
Yes, sir.
recursion? What is recursion? Excuse me, guys. What is recursion?
Function inside a function.
Function inside a function, and function is that is
Repetitive.
calling the same function again and again. That is called recursion.
basically calling yourself.
Repeatedly calling yourself. That is
Yes, sir.
called recursion. So in this case, E derives E star E. In this case, this E can call it again. Am I right?
Yes, sir.
Right.
And this E can also call it again, right?
Right.
Yes, sir.
And in this case, this E is on the leftmost side. That's why it is called left recursion, right? In this case, it is on the rightmost side. That's why it is called right recursion. Now you got the problem. As in this grammar, both the recursion might be possible. That's why the rule of associativity is broken. So our first reason of ambiguity is called associativity. In this grammar, this term is left recursion. This term is right recursion. Because of left recursion, we got wrong answer. Because of right recursion, we got correct answer. So what we need to do? What we need to do?
Left side terminal রাখবো।
Left side we are going to stop. Let's stop left recursion. So how can we stop left recursion? E derives.
T
Oh,
star E.
I'm wrong, guys. Because of left recursion, we are getting right answer.
Answer left. We have to stop the
Right
Right.
answer for the right recursion, we got the wrong answer. Thank you. So let's stop right recursion. Yes, thank you. For left recursion, we got the correct answer. For right recursion, we got the wrong answer. So we have to stop the right recursion. How can we stop the right recursion?
E star T.
E star D.
E star, we're stopping here. Just put
T.
the terminal, which is
terminal.
nothing but ID.
ID.
And ID. Now see what happened. Now there is no more this one. So we got only this one. Now our associative problem is solved. Is it clear to you?
জি।
Yes, sir.
Now this grammar also becomes unambiguous.
কি বলো?
Okay, guys. So what is the catch line? Star has left association. That's why we have only left recursion. Star has left association. That's why only left recursion. So catch is if any operator is left associative, we should have what? We should have
Left recursion.
only left recursion. Only. On the other hand, if any operator has Right associative? Then what? Then what? We should
Right
have
to the only right to
Right.
we should have
Only.
Is it clear to you guys? Do you have any question? Cody.
জি না স্যার
Now Ankur might say, sir, you are silly. What is wrong with here? Nothing is wrong here. The answer is actually same. So no problem with this. Now let's go to second reason of ambiguity, which is called operator precedence. Let's take this grammar. E derives E plus E or E star E, or let's say now. Is this grammar ambiguous or not?
Yes, sir.
মনে হচ্ছে অ্যাম্বিগুয়াস স্যার
In morning, what a can
It is ambiguous.
It is, sir.
we have already encountered this grammar 5-6 times. Why it is monoic?
Left recursion আছে, right recursion আছে.
না এই গ্রামারটা যে ambiguous এটা আমরা we have already proved.
আচ্ছা রাইট
Am I right? What is the string? নাম plus ID না এখানে নাম দিয়েছি. Don't memorize. Let's take this string. Now, what are the parts tree? E derives E. Tell me.
plus E,
E plus E.
Plus E.
E star E.
তারপরটা হলো নাম স্টার ই।
Let's take another one. E star E. Naam plus naam star naam. Same in. Which one is correct? If we replace this naam with 2, this naam is 3, this naam is 4. Again 2, 3, 4, and this is actually plus operator of arithmetic, and this one is star operator of arithmetic. So whole thing boils down to 2 plus 3 star 4. What would be the correct answer?
14
14.
The answer would be 14, right? 14 would be correct answer.
So
Now,
NND.
in this case, what would be the answer? This is naam is 2, so this one become 2, then this one becomes 3, so this one becomes 3 star 4 equal to 12, this one becomes 12, ultimately we got 40. Am I right? So correct answer.
yes, sir.
Now how about this? This naam is 2, this naam is 3, so this one become 2 plus
5.
3 equal to 5, so this one
20.
become 5, this one become 4,
20.
then ultimately the answer becomes 20, which is the wrong answer according to our
Yes, sir.
arithmetic, right?
হ্যাঁ স্যার।
Both parse tree generates the same string. Did you
Yes.
understand? But one leads to correct answer according to arithmetic, another one leads to wrong answer according to arithmetic. Which one is correct answer? 14. Which one is wrong answer? 20. Now, how can you get rid from this kind of problems? Now see, ambiguity is a problem. Did you understand, Rangpur?
হ্যাঁ স্যার বুঝছি
If you give this grammar and generate actually your parser using this grammar, then what happened? One time it might generate this, another time it might generate that. You have no control over your result. One time it will give correct answer, another time it might give wrong answer. If you don't have any control over the grammar. So that would be wrong. Only 40 should be always generated. So that's why we can never use ambiguous grammar in parser generator. Now tell me, how can I get rid from this problem? This problem, this ambiguity is also called operator precedence. So, reason of ambiguity, another reason is operator precedence is broken. So how can you get rid from this one? How can you get rid from this problem?
মাল্টিপ্লিকেশন আগে করতে হবে স্যার।
Yes, so we have to do the multiplication first. In this parse tree, multiplication is happening fast. In that parse tree, multiplication is happening later. So why multiplication is happening here first in this parse tree, and why multiplication is happening later in that parse tree? Can you tell me?
কারণ প্রথমটাতে স্যার রাইট রিকারশন,
প্রথমটাতে রাইট রিকারশন, কোথায় রাইট রিকারশন?
প্রথমটাতে স্যার মানে লেফট সাইডে।
No, wait.
Sir, each
No,
time.
মাল্টিপ্লিকেশন আগে করা হচ্ছে দেন প্লাস করা
Yeah, I
হচ্ছে
understand. He said here there is left recursion. Here there is left recursion.
No, it doesn't have anything with recursion.
Oh,
here.
wonderful. Can you give me the answer of this? Why there is no recursion happening here? Recursion does not matter here. Can you give me an example?
Because the first one is E plus E and the second one is E star E.
Wonderful.
So
We are not calling the same product again.
It's not the same.
We are not calling the same product again. Wonderful answer, Samira. In
Really?
this case, what is my answer? In this case, see, in this case, we are calling the same product again and again. In this case, we call the same product on the right side. That's why it is right recursion. In this case, we call the same product on the left side. That's why it is left recursion. But in that case,
we are not calling the same instance.
we are not calling the same product. So it is not recursion problem. It is not recursion problem. So the problem is somewhere else. So what is that problem? Here we called E plus E. We called here E plus E. And here we replace E by E star E. It is not problem with recursion. Recursion is all right. Now tell me, what is the problem?
The plus operator has lower precedence than the multiplication.
Multiplication. But all the answers are correct. Here the star operation is doing first before plus. And star has more precedence than plus. I agree. But
Right.
how do you control in this parse tree this operation? How do you control that one? What is the mechanism of
স্যার
control
যেটার
there?
প্রেসিডেন্স বেশি ওইটা একদম
ওইটা একদম
so ওখানে
যে প্রোডাক্টের
একদম বটমে থাকতে হবে
বটমে থাকবে। I got answer. হ্যাঁ, আর কি what else is the answer? Tell me. What else is the answer?
স্যার আমি
Highest.
No, Ankur, you are right. Ankur, you are right.
বটমে থাকবে
Ankur, you are right.
Okay.
The more precedent operator should be in the bottom side. That is correct answer. Any more answer actually. So it is right. So here it is generating correct answer because star has higher precedence. High precedence and in the deeper branch of parse tree. Absolutely right. And here we do the reverse thing. Here star has highest precedence, but still we do plus operator on the deeper side of the branch, deeper branch of the first tree. That's why it is wrong answer. Now, how can you write this grammar? How can you rewrite this grammar so that star would be in the deeper side? How can you do that one? At first, let's broken out. So first one is, this one has recursion in both sides, left recursion and right recursion. Plus is only what? Plus is only? Tell me please. It also has associativity problem. Am I right?
Yes. Right.
Because it has left recursion and right recursion. Oh, so you have to fix that one at first. Plus is what recursion? What type of recursion?
Associative.
What is the associativity of plus?
Left precedence.
Left.
So there will be only recursion term on the left side. Right side there will be no. There will be no.
মানে এখানে রিকারশন হবে না।
রিকারশন হবে না কারণ এই সেম एग्जांपल if you instead of star we have proved the associativity problem for star. If you take this grammar, E derives E plus C or ID. It is also ambiguous. Am I right? Instead of star, if you put plus, it is also ambiguous. Am I right? What is the reason behind? What is the reason behind ambiguity here?
Recursion.
Recursion. That means associativity. Am I right?
Right.
Same. Just replacing star with plus. All the example replacing star with plus. Still, you get some problem. Am I right?
Yes, sir.
Absolutely.
So in this grammar, the final grammar, there are two types of problem. There are two types of problem. One problem is because of operator precedence. Am I right? Plus and star. Another problem is because of associativity. In this product also there is a problem. What is the problem?
Associativity.
Associativity. So we have to fix that one. It is also left recursion. So we have to disregard this one. We have to keep this one. We have to keep this one. We have to disregard this one. So first problem is done. The solution of first problem is done. Now, how can you give the precedence? The star over plus. How can you give the precedence?
Start symbol.
Start symbol has higher precedence than plus. How can you rewrite the grammar so that we can get that solution?
So we can introduce another variable.
So we should rewrite grammar in such a way so that whenever we enter in star, no way we can go back to plus. Am I right or not?
Yes, sir.
In this case, if we write E star E, then we can also derive E plus C. Am I right? That is wrong. That is the problem. Am I right? At first,
Yes.
E becomes E star E. Then again, this E becomes E plus C. So, at first, doing E star E, deriving E star E, then deriving E plus E. We have to stop this. We have to stop this. So, how can we stop that one? How can we stop that one? Once we enter in the star operation, we cannot return back to plus operation. So how can we reflect this thing in the grammar? So let's write this one. E derives E star E plus T. So there is no right recursion, right?
Right.
Yes.
Right, sir.
So we are done with associativity problem. Now let's do this thing. T derives T star M. Here there is no right recursion. So we are done with associativity problem. Finally, let's write M derives ID. Is it clear to you? Now see, once you go to T, you cannot return back to plus operation. All right? And whenever plus and star both there, at first, high level, I'm going to generate E plus T. Then the lower level, I'm generating star operation. So it is correct grammar. Am I right or not? Is there any question on that?
No
Sir,
question.
So did you write this grammar according for this string num plus num star num, or like
Okay. Let's put it num here. Now, right.
okay, sir.
So here there is no right recursion, only left recursion. So done. Here there is no right recursion, only left recursion. Associative problem is done. And how do we resolve star and plus? Once I enter in star, I cannot return back to plus. And whenever plus and star both are there, at first top level we are derived to plus, then after finishing plus we are deriving star. So we are done with this. Is it clear to you? Yes. You have to speak, otherwise I cannot understand.
Yes, sir.
কি স্যার বুঝেছি
Sir,
Yes, sir.
স্যার এই গ্রামার যখন স্টার্ট সিম্বল থেকে শুরু করব তখন ই কে রিপ্লেস করার মতো কি আছে?
কে রিপ্লেস করার মতো খালি শুধু এটাই আছে, ই প্লাস টি, আর কিছুই নেই।
আচ্ছা,
স্যার তাহলে ই বারবার আসবে না?
তাহলে তো স্যার ই বারবার আসবে, তাহলে
There is one problem. You are right. There is one problem. So how can I stop this recursion? Tell me. You always will come. It will
আরেকটা
never-
প্রোডাক্ট অ্যাড করে দিলাম যে
আরেকটা
ই
প্রোডাক্ট এন্ড করতে হবে so that I can
derives
go to
M.
next layer.
Okay.
So that I can go to next layer. Wonderful answer. So let's put it here T. Again, in this case, T would always come. So I have to stop this recursion. Let's put there M. Now we are done. Let's rewrite this grammar. E derives E plus T or T. T derives T star M or M derives none. In the first product, there is only left recursion. So that's why plus is only here left associative. In this product, there is only left recursion. That's why star is only left associative. And as the level of star is under plus, that's why star has higher precedence. Is it clear to you guys?
Yes, sir.
Now this grammar
Absolutely.
becomes unambiguous. Unambiguous. Okay, guys? Is it clear to you?
Yes, sir.
স্যার
Yes, please.
স্যার আমি যে গ্রামারটা লিখেছি সেটা হচ্ছে ই প্লাস টি, তারপরে হচ্ছে টি,
হ্যাঁ।
আর টি থেকে ডিরাইভ করব হচ্ছে টি স্টার টি অর নাম।
না, তাহলে তো এটার ইয়েটা হলো না। আপনি যেটা করলেন তার ফলে স্টার is become both left associative and right associative both.
আচ্ছা,
Then star would become both left associative and right associative. Then if you take this, let's say now he wrote this E star E plus T or T derives T star T or num.
Num.
Now let's take this num star num. Let's take this. Then what happened? E derives E plus E derives T, then this T derives T star T. Then if we replace this with T star T, and in this case, replace with T star T, if we replace this T with T star T, still it is ambiguous. Am I right?
Yes, sir.
yes sir.
It is ambiguous, so it is wrong. Because you did not terminate what? You did not terminate
the right recursion
right recursion. So we have to do both. In this grammar is ambiguous because of both operator precedence and the associativity. So single rules, I break out the associativity and putting the higher operators in the bottom, we keep retain the operator precedence. All right, guys?
Yes,
Is there
sir.
any question?
Yes sir, thank you sir.
Okay. Now tell me what is the operator precedence here? If we have plus on left and plus on right, which one is higher?
Left.
Left one. So we denote it by a greater than and a dot symbol there. Okay, guys? Then Star and star, left star and right star. Which one is higher precedence?
Left.
Left.
Plus and star, which one has higher precedence?
Star.
Right.
This one. And star has also less precedence than none. Do you agree with me or not? Because none in the left bottommost position. Okay, guys? So remember this. This kind of things might be given in the exam. All right. So let's do some examples. Let's do some examples. Is it fun or not?
অনেক মজা স্যার।
So
Yes, it's fun.
always remember, whenever associativity is concerned, you have to stop one recursion. If the operator is left recursion, then you have to keep left recursion, you have to stop the right recursion. If the operator is right associative, you have to keep the right recursion, stop the left recursion. And another thing, if there is an operator precedence is there, the higher precedence operator should be on the lower level of the grammar. Lower level of the grammar. In this case, star is higher precedence, that's why it is in bottom of class. Okay? So let's do an example and see if people understand it better. Let's take this grammar. Today the video quality is wonderful. I'm getting very fun taking classes. This should be the video quality. Am I right?
Yes, sir.
So let's take S derives S question mark P or P. P is nothing but P hash T or T. T is nothing but Q wiggle T or ID. Okay, guys. So here the variables are S, P, T, Q. What are the terminals? Question mark, hash, wiggle, and ID. Now tell me, question mark and question mark, which one is greater? Left question and right question, which one is greater?
রাইট।
Let's go to this product. Here the recursive term is in which side?
লেফট।
And how about the right side? Is there any recursive term?
জি।
G kothay? The symbol starts from S.
হুম।
So S we can replace with this. This S can be replaced with this. This S can be replaced with this. So what would be the recursive term here? S. Am I right?
Right, sir.
Yes.
Right, sir.
রিকার্শনটা বুঝছেন না কেন? E derives E plus E. This E can be this E you can consider as this E. Then you can replace with this product. Then again this E can be considered as this E. Can be replaced with this product. Am I right?
হ্যাঁ এটা তো
E can be E plus E. Then this E can be considered this E and replaced with E plus E. Plus E. Then this E can be considered again this E can be replaced with this product. E plus E plus E plus E. This way it will continue. Then it is called recursion. Am I right? But if I write T derives E plus E, is it recursion?
না
This is not E. This is T. So how can you use this product? Am I right? In this case, left side there is a S. On the right side, leftmost position there is a S. So what type of recursion is this?
লেফট রিকার্সন।
Left recursion. What is on the rightmost position?
ই।
Is this actually S?
না।
So is it recursion?
Na, sir.
No, sir. Talo, if there is a left question mark and right question mark, which one has higher precedence?
Left one has higher precedence.
Left one has higher precedence because it is left recursive. Is it clear or not? S becomes S question P. Then this S can be considered this S. So you can replace with this product. So it becomes S question mark P. Then if this S can be considered this S, it can be replaced with this. So it becomes S question mark P. But can you replace this P with this product? Of course not, because left side is S. Am I right?
Yes, sir.
জি।
Yes, sir.
Now let's take hash. Hash and hash. Which one has higher precedence?
Left.
Left one. Now let's take wiggle and wiggle. Which one has higher precedence?
Right.
Because recursive term here left side is T and the recursive term on the rightmost position. So right one is higher precedence. Is it clear to you guys?
Yes, sir.
Now if you take question mark, hash, wiggle, ID, question and hash, which one has higher precedence?
Hash.
Sir, wiggle.
Question and hash. Between these two.
Hash.
Sir, we
Oh,
Question and
Hash.
hash.
Question and hash.
Because hash is on the lower
hash,
side.
hash.
Hash is on the bottom side. Then hash and wiggle, it is more bottom. So
Wiggle,
this. And
wiggle,
ID
wiggle.
is at the and wiggle and ID, which one has higher precedence?
ID.
Tell me, which one has higher
ID.
precedence?
ID.
ID, sir.
Is ID in the lower side? They are on the same level.
Yes.
So they should be same.
Also left.
Abar
Same,
bole
same.
left.
Sorry.
They are on the same level, so they should have same
Oh.
precedence.
Okay.
You people are funny. Don't memorize. Memorization is very bad. It will destroy you. Is there any other reason for ambiguity? Is there any other reason for ambiguity? There is another type of ambiguity which is called dangling else ambiguity. That is called dangling if you write this grammar, let's say expression implies if is this grammar ambiguous or not? Is this grammar ambiguous or not? Guys, is this grammar ambiguous or not? Hello, guys.
Sir,
Is
Sir,
this grammar-
ambiguous.
is
sir,
this grammar
if এর
ambiguous?
মধ্যেও ই
If
আছে
you take this, if A else B, then C, I can generate two parts. E derives, by the way, if is A are terminal, if else are terminal, ABC are terminal. Okay, so E can generate if E, then this E can be replaced with if E else E, then this E can be replaced with A, this E can be replaced with B. If A else B, same yield. Am I right?
Yes,
What
sir.
would be the next parse tree? What would be the next parse tree? E derives. Let's replace with this. If E else E. Now this replace this E with if E. Then replace this E with A, this one with B. What would be the yield? If A else B. Same yield, but two different parts. So this type of ambiguity is called dangling else ambiguity. Can you tell me what is the reason behind this dangling else? What is this? What is this grammar? How can you relate this grammar with language, computer language?
Conditional.
Conditional. So whenever we write if A if we write this way, if something, if, then A, else B. So the problem is, in the language, this else, which one it is connected to? Which one this else is connected to? Whether it is connected with this if or this else is connected with this if. That is the reason behind this ambiguity. Is it clear to you guys?
Okay, sir. So it gets confused between who the
Between-
parent is.
With parent of if. Parent of if. In this case, what is the parent of this else? In this case, it is like this, right? This else is related with this if. Am I right?
Sir.
Because these two are in same level. Same level. On the other hand, in this case, what is the relation? If, then else, then if. Am I right?
Yes, sir.
Am I right?
Right.
So here the else is related with the first if. So as this else is dangling without having fixed position with if, that's why it is called dangling else problem. We'll stop here today. Next class we'll start again solving this problem, but it is your homework. It is your homework. Go to Red Dragon book or any dragon book. You'll find this problem, dangling else. You'll try to come up with two solutions. So this grammar is ambiguous. Am I right?
Ji.
This grammar is ambiguous. So you have to come up with two solutions. Already in the dragon book, one solution is given. In that solution, most probably they always connect this else with the previous if. Immediate previous if connecting. They are connecting this else with possible immediate previous if. But you have to come up with two solutions. In one solution, you will join this else with immediately previous if, and another solution you have to connect this else with the first possible if. So one way you have to connect with the topmost if, another way you have to connect the else with the bottommost if. One solution, most probably this solution is given in Dragon book. But you have to also solve this problem. So that would be your homework. All right, guys, we should stop here today. Do you have any questions?
Okay, sir.
Is the
Sir.
today's topic clear to you guys?
Sir, reasons for ambiguity with 3টা পয়েন্ট আরেকবার দেখেন।
Of course. And did you get my actual lecture notes? Did you get my lecture notes?
Yes, sir.
Yes, sir. Yes, sir.
Notes.
Image files.
Yes, sir.
Image files?
Yes, sir. হ্যাঁ, sir.
Yes, sir. So these are the three reasons of ambiguity we have studied.
Sir, is there any formal proof যে আমরা কোনো অ্যালগরিদম বের করতে পারবো না
যেটাতে
ambiguity?
no. Wonderful question. Who asked me this question?
Sir, me.
Who is this me?
Sir, Mahmudun Nabi.
Sir, read
Mahmudun Nabi. There is no algorithm to prove whether a grammar is ambiguous or not. You have to try. In general case, hit and run method. There is no algorithm to convert any ambiguous grammar to unambiguous. No algorithm is there. If you can invent an algorithm, you will become a Turing awardist. So those are again hit and run method. There is no algorithm. It is a good question. There is no algorithm to convert generally any ambiguous grammar to unambiguous grammar. So that's why human excellency is there. Human is more powerful, more intelligent, more humanly, more magnificent, the best creature of God. That's why. Machine can never compete with human. Is it clear to you guys?
Yes, sir.
So these are the reasons of ambiguity. Associativity is broken, operator precedence is broken, and there is a special one, dangling else ambiguity. Is there anything else?
Again, like just a side question. কোনো কি
Yes.
তার মানে মাহমুদুল নবীর কোয়েশ্চেনটাই আর কি বেসিক্যালি কোনো প্রুফ কি আছে যেটা বলে যে there may be possible for an alternative to the hit and run method?
No, there is no. There is the algorithm there whether to prove a grammar is ambiguous. There is research is going on, but still we did not come up with any algorithm. Yes, no
আচ্ছা।
algorithm.
মানে
তো টিউরিং অ্যাওয়ার্ড যে
ফর্মাল
সলভ করবে
প্রুফ আছে নাকি যে
It is of course a Turing award winning problem. Of course, it's a Turing award problem.
ওকে
Of course, definitely a
Understood.
Turing award winning problem. Any more question?
জি না স্যার
Any more question? No, sir. Should we stop here?
স্যার
today?
কি নোটগুলো দিয়ে দিলেন স্যার?
অবশ্যই দিয়ে দেবো। আমাকে একটু সময় দেন। রাতের বেলা কি যে হয়, রাতের বেলা the downlink is fine, but upload link is so bad. Most probably everybody is uploading many things in YouTube and other places. I don't get any upload link. All my servers are down yesterday, and then I cannot upload anything actually. Give me a little time, okay?
Sir, we have a class on this Thursday, makeup class.
Yes, we have to take that class.
ওকে স্যার
Any more question?
নো স্যার
Should we stop here today?
ওকে স্যার
Okay, see you then this Thursday. Okay, bye bye.
বাই স্যার
Have a
Bye
nice-
bye.
Have a good night. Take care. Bye.